Hey everyone. In this note, we're going to take a look at pseudocode. So, pseudocode is just like looking at some code and trying to modify it and see if we can understand what's going on with the code. So, the first definition that we have here is an algorithm. So, it's a set of instructions that specify exactly how to solve a problem in a finite number of steps. So, a finite number of steps means a number of steps that you can actually like count. It doesn't go on forever. So, for example, an algorithm to determine the largest bill currently in your wallet, you can go ahead and take a look at this list of steps right here. I'm not going to read it out loud to you, but please pause the video and read through all of these steps so you can understand what's going on with this algorithm. So, if you notice right here, this is a list of steps that you need to do in order to achieve a certain goal. So it says right here to use the steps below to create an algorithm for changing a light bulb in a ceiling light. So it's really important that we do everything in the right order. So go ahead and read through what's written here, and I want you to see if you can figure out how to put this in the proper order. So again, pause, try this yourself, see how you do, and then from there, check to see if you agree with me. So, hopefully, you may have said that step one that we need to do right here is to just check to make sure that the light is off. So, step one, if the light is still on, we're going to turn off the light. Okay. And then once we turn off the light, we have to make sure that if it's hot, it's cool enough for us to be able to change the light. So, we need to do step two, is to wait until the light is cool enough for us. Then after that, we need to be able to get up and be able to reach the light. So step three is to get a chair, a ladder, or a sturdy tool. Once you do that, it says we need to actually take the light bulb out. So we're going to turn the existing light bulb in a counterclockwise direction until it is loose from the socket. Then after that, we need to put that light bulb somewhere. So step five would be to place the old light bulb in a safe place and then pick up the new one. Then once we pick up our new light bulb, we need to place a new light bulb in the socket and turn it in a clockwise rotation until it's firm in the socket. And then lastly, we're going to dispose of the old light bulb and put away the chair, ladder, or stool. So this is an algorithm because it is a list of steps. We also see algorithms in math. So describe the steps required to solve the problem. So BEDMAS is an example of an algorithm in math. So if I take a look at question number one right here, according to BEDMAS, I have to do my brackets first. So the first thing I'm going to do is find the value from the brackets. By adding 3 and 7. Once I know the sum of 3 and 7, my second step is going to be this multiplication that we have right here. So I'm going to multiply the sum from step 1 by 4, and that will give me my answer. Okay? So in number 2, the first thing that we need to do, the first step that we need to do is we would want to collect like terms. So step 1 is going to be to collect like terms. And let's actually do this on the side so we can see what we're doing. So I get 15 equals 5x minus 7. The next step is going to be to add 7 to both sides of the equation. Step 3, so when I add 7 to both sides, I would end up getting 22. Step 3 would be to divide both sides by 5. And then that would be my answer. Step 4, write the answer. Okay, in number 3, it says determine the area of a circle when the diameter is 3 meters. And remember, the area of a circle is pi r squared. So the first thing I need to do is find the radius because I'm only given the diameter. So step 1 would be to find the radius by dividing the diameter by 2. Then I would take the radius and square it. And then lastly, I would multiply the results from step 2 by pi. And then my next step, my last step, I know I said lastly for step 3, but step 4 is actually my last one. Write the answer based on how our directions tell us. So if our directions tell us to round, we would round. If our directions tell us to leave it as an exact answer, we would leave it as an exact answer. I'd like you to do this one on your own, and then we will take it up in class. Okay, next we're going to be talking about Boolean logic. So Boolean logic, the learning goal is to understand the functions of Boolean operators, which are and, or, and not, and use them correctly in programming. So what are Boolean values? So when you have a statement, you can take that statement and assign it a Boolean value. And there are only 2 options when you have a Boolean value. Those options are either true or false. And they're used to represent truth values of statements. So what are Boolean conditions? A Boolean condition is a comparison between 2 values that evaluates to true or false. So for example, today is Monday. I'm going to have you fill this out because I'm not sure what day you're actually watching this video. So you can determine if this is true or false yourself. The next statement is 5 is greater than 7. And 5 is greater than 7 is a false statement. This is not true. Okay. And then lastly, we have this last one right here, but I don't even know what this even means. So let's look at what the Boolean operators are. So Boolean operators provide the criteria for comparison in a Boolean condition. So the operators are either and, or not. And these statements right here, this would mean not equal to, which is different than what we write out on paper, but using computer language, it would look like this. And then equal to is different than what we would write on paper. Using computer language, quite often we would write it like this. Of course, it depends on the language that you use, but this is typically what we would have. This is greater than, this is less than, this is greater than or equal to, which when we write on paper, we write like that. And then this is less than or equal to, but when we write it on paper, it looks like that. These look like smiley faces and angry faces, but these mean greater than or equal to or less than or equal to. So this is saying the statement orange is equal to the statement red. It is not true, so this is false. Now we did discuss the word and the word or in class, but just a reminder, an and statement is true when both statements that are connected by the word and is true. So in other words, you would have true and true. Otherwise, it's false. So if you have true and false, it's false. If you have false and true, it's still false. And then obviously false and false would be false. So for example, you are in grade 9 and 5 is less than 7. Well, you are in grade 9 is a true statement, and 5 is less than 7 is also a true statement. And because they are both true, then the whole answer to this is true. This is a true statement. All right, in the next example, it says you are in grade 9, which we've already determined is true. And The next statement here says 8 is less than or equal to 9, which is also true. And the last statement here says orange is equal to red, which we know is false. Well, right here, these two statements together are true. And we're going to combine that with a false statement. And just because we have this false statement right here, the whole entire statement is going to be false. Now, an or statement is true when either both statements are true or one of the statements is true. Otherwise, it's false. In other words, it's only going to be false if both statements are false. So, our first example right here says you are in grade 9. That is a true statement. Now, this time it says or 5 is greater than 7. So, this one's a little bit different. That's not true. 5 is not greater than 7. So, that's false. But is true. So as long as it's one or the other, that's all that matters. So as an end result, this whole statement is true. All right, and then in the next example, it says orange is not equal to red. Notice right here, this statement right here means not equal to. So this is saying orange is not equal to red, which is a true statement. Or we also have 8 is less than or equal to 9, which is also a true statement. Or 5 is greater than 7, which is a false statement. And because these two together, true or true is true, and then we have or false right here, these two statements together are false. These two statements together are also true. So this is a true statement. As long as one thing that you're saying there is true, the whole entire statement is true if it has or in there. Okay, and then lastly, not. Not is the opposite of the truth statement. So if I have a statement and I say not in front of it, then it's going to be the opposite of whatever the original statement is. So for example, right here, if I look at this right here, this statement 5 is greater than 7 is a false statement, but there is an exclamation point in front of it. So this means that it is not we're doing the opposite of 5 is greater than 7. So that means that the answer here is true. This is saying 5 is not greater than 7, which is true. Okay, and then lastly, in the last example that we have here, the red is equal to red. This is a true statement. But then this is saying not right here. So that means that the final answer will be false. But in other words, this right here is saying red is not equal to red, which is a false statement. Okay, and that's it for this video. Let us know if you have any questions, and we will see you in class. Bye.